So now our definitions and theorems for regarding concavity. If we, and I remember that I'm including the page numbers because I want you to trace this discussion back to the text because the text has the information in it that you need. Definition on page 217 of concavity, if you've got a differentiable function on an interval, then we say that f is concave up on that interval if the first derivative is increasing on the interval from a to b. So essentially, you need to find the first derivative. To check concavity, we need to find the first derivative and see where it is increasing. How do you tell if a function is increasing? You take the derivative of that function. Now that gets a little confusing because we're talking about taking the derivative of the derivative. We put all that together in the test for concavity next. Right? So, but the definition of concave up is that the first derivative is increasing on the interval, as it was on the sine function here on the interval from pi to 2 pi. From pi to 2 pi, the first derivative indicated by the slopes of the tangent line is increasing. Here it's negative, and then it's going to 0, and then it's going up to positive. That's an increase. Negative to 0 to positive is an increase. We say by definition that f is concave down on an interval if the derivative is decreasing on that interval. For example, positive slope, 0 slope, to negative slope. So on the interval from 0 to pi, that function is concave down. We're just making mathematically precise the intuition that we built in the previous video. But it's not practical to just draw little approximate slopes of tangent lines all across our function. We need an effective test to test for concavity. So what we do to test for concavity is, assuming that the second derivative exists, where that second derivative is positive, our function is said to be concave up. This is a theorem regarding concave up and concave down. The previous was a definition. Here's how it's defined. Here's how you figure out practically if your function is concave up or concave down, or where it's concave up or concave down. The second bullet is if the second derivative is negative, then your function is concave down. That's not too hard to just remember because negative sort of corresponds with down and positive sort of corresponds with up. But it's also not too hard to understand if the second derivative is positive, that means that whatever function it's the derivative of is increasing. Well, the second derivative is the first derivative of the first derivative. And by definition, the function f is increasing when the first derivative, the function f is concave up when the first derivative is increasing. So it's not too hard to remember just by the correspondence of these pieces, but it's also not too hard to understand. Then another significant feature on a graph is a point of inflection. We say that the point P, so give it a short name, and then points have two coordinates, so C and F at C, is a point of inflection if the concavity changes from up to down or from down to up at x equals c. So let's have another little miniature sine graph here. Here our function is concave down. It's like a downward shaped bowl or a downwardly placed bowl. And then here something obviously changes. It looks like an upwardly placed bowl. This point right here is a point of inflection. We call it a point of inflection, and it is a point where the concavity changes from down to up. Similarly, we could have a point of inflection where the concavity changes from up to down. Then a test to find inflection points, essentially you just look for where the concavity changes. So if the second derivative is 0 or the second derivative doesn't exist and the second derivative changes sign at x equals c, like say for example it's negative to the left and positive to the right, then you've got a point of inflection at x equals c. Okay, and we'll in the next video work a few examples that are also in the text because I want you looking at those examples in the text. We don't work them all, but hopefully we fill in the gaps in the prose that's written in Rogowski.